Hello, everyone. This is Gunnar Anderson with Cisco Systems. I'm the product manager for the CSP 2100, and I'm here with Avi Networks, and we'll be doing a joint webinar. So thank you, everyone, for attending. So at this point, I'm going to turn it over to Nathan, and he'll be going over a few slides covering Avi, and then he'll turn it back to me, and I'll cover a few things on the CSP 2100. Go ahead, Nathan.
All right, thank you very much. Hi, I'm Nathan McMahon, Solution Architect with Avi Networks. And a little bit about Avi Networks and a little bit about how and why Avi is applicable and relevant to the CSP platform. So Avi Networks is a software-based application delivery or load balancing solution. So why is that relevant for the CSP is that as people are looking for next generation of load balancers, they're looking for a platform that to run this on that's going to be high performance, that's not going to be a snowflake, that's something that's a repeatable solution, and that's where Avi and CSP work perfectly together. So for a little bit about what this means is that when you talk about network services such as load balancing or GSLB or web application firewall or firewalling, any of these types of network services, what you find quite often is that these network services are very much a bottleneck. You have a predefined amount of hardware, the size of what you purchase, and that's what you get for the next 5 years, and that's kind of what you're stuck with. But if you look across the industry, you look at things like the applications that something like a load balancer load balancing, these applications, they may grow, they may shrink, they move around. They're completely fluid, and they're just simply taking advantage of x86 compute. But if you look at something like that load balancer, it's a very rigid capacity. It doesn't change, it doesn't shift. This is what you've got, and that's kind of what you're stuck with, is because that's a proprietary device that doesn't have any type of agility with it. So what Avi is all about is taking that network services and saying, we want to be able to make this be horizontally scalable. We want to make it so that you can deploy these applications however, wherever, and your network services have that ability to deploy with them with that same level of capacity and fluid capabilities. So what Avi has done is Avi is pure software. We've separated our software, though, into a controller, which manages the entire load balancing fabric across the organization, and then our service engines, which are our lightweight load balancers. These load balancers can be pushed out to wherever the applications may exist. And in an environment like this, we can have different size load balancers. We can have one bare metal CSP that's running one Avi load balancer, or we can divide this up into things like context or virtualize it so that you've got 10 or 20 load balancers on one CSP device. All of this, though, is going to be managed from one single location, from that one controller. And why this is important is that you simply have load balancing capacity now across your entire organization. And if you have however many load balancers you have, instead of having these pairs of active standby load balancers, you instead have simply one fabric, and that fabric is horizontally scaled. That means that if any one load balancer fails, you simply have a little bit less capacity across the entire system, but the rest of that fabric can pick up that capacity. And you can then, with something like CSP, you've got infinite hardware capacity available to you. You can simply just go and redeploy or reprovision a new load balancer on the fly when you need additional capacity. And so it's nice because all of this is now being managed from one central location. You're not logging into every individual load balancer or into every load balancer pair to manage them. They can all be done from one place. And that can be something where it's from a GUI, from a CLI, or for the DevOps folks, they can fully automate that via REST APIs. And this fabric will then tie directly into a number of services as well to be able to automate and work with existing orchestrators if that's going to be something like an OpenStack or whatever the case may be that this may be deploying into. So by having that distributed, horizontally distributed and scalable architecture, that allows us to then simply go and add capacity in a Lego block style. So if you've got, let's say you start out with you using 1 gigabit of throughput for your load balancing, and then later on more traffic comes in, more applications are deployed. What this means is that we can simply deploy another CSP, throw Avi on there, and you've now doubled your capacity. And we can keep scaling this out, and we can horizontally be able to scale out this capacity so that instead of these, this load balancer is for this application and that one is for that application, we simply say, I've got this much capacity in my network, and as long as I've got available capacity, I can keep growing that, my load balancer, I can keep growing my firewall, I can keep whatever my network services that I'm running on this. So that's a bit of what the software that Avi is providing. is doing for us is it's providing that scalable services that you've been used to from other products such as like the Cisco ACE or the GSS, or from other products like an F5, for instance. So from a scalability or a capacity perspective, we can simply take over one CPU core on something like a CSP, or we can take over the all CPU cores on this. And one CPU core can push a significant amount of traffic, and if you keep adding on capacity or consuming additional capacity, we can scale up the size of this. Under the hood of every load balancer that you purchase from any vendor, it's going to be x86 CPU, and what you'll find is that on something like a CSP, traditional like a mid-range load balancer today will be something like 4 Intel x86 vCPU cores. And if you compare that to something like a CSP is going to have about 10 times that compute capacity. So the numbers are really quite staggering of what you can scale this out to. It's really quite impressive. And the other thing that's really nice is that not only are you scaling up a single load balancer, but you can scale out across multiple load balancers and distribute across multiple load balancers. So Avi can work with other Cisco components such as the routers and the switches and things like Cisco ACI, and you have the ability to also scale out and seamlessly have one load balancer simply become 2, 3, or 20 and scale out that capacity horizontally. And so really what this comes down to is you have the ability to take a single load balancing fabric and have it scale out to multiple terabits of throughput, rather than having to purchase and allocate very specifically, this application goes on this load balancer because it has this much capacity available. You're simply now moving from that kind of isolated islands of technology, and now we can move towards more of just a central distributed fabric that's all centrally managed. So kind of under the hood of what this would look like on CSP, CSP is pretty cool. It's not a server, it's as an appliance. It's providing the Intel CPU and the compute for us. It's providing the interfaces and such that we can drop into whatever the network is going to be. On top of this, we lay down KVM, and then Avi installs on top of this. But effectively, it's a complete packaged appliance that gives us a significant amount of scalability, lower TCO, et cetera. And this is something where this CSP platform can be used for something like Avi. It could also be used for firewalls. It could be used for other network services. So from this one platform, you can now have an expandable and extensible network function virtualization, which is very cool. And so in this case, Avi would be one of these network functions that you can scale. So I'm going to turn it over to Gunnar to talk just a little bit about the underlying architecture and how this does what it does.
Thanks, Nathan. Yeah, so I'm the product manager for the CSP 2100. I've been kind of with this for about 3 years now. So the reason we kind of came up with this appliance, and we've been thinking about this and working on this for a few years now, is really to come up with a way for load balancing teams, network teams, and security teams to make the transition to NFV. And these were some of the challenges that we saw in the marketplace, really keeping pace, like if I go through these, with the server team being able to spin up virtual services, or in this case, network services, virtual network functions, within a matter of months. We also built this on Linux. We want to get away from proprietary hypervisor costs. OpenStack is also very pervasive in the NFV community. But it's also, very complex. In most cases, there's a lot of overhead, so you need, 7 or 8 management and control nodes to get started. In a lot of places, that's simply too costly. There's also organizational challenges, being able to have access to the right tools to, control your destiny, being able to, spin up these services. The other thing that we did with the CSP 2100 is we made it very easy to use. So we leveraged something called ConfD, which we picked up from our tail acquisition about 3 years ago. So we've abstracted away the complexity of Linux. So essentially, you have 4 ways to interact with the platform today. We have a full-blown GUI. You can use a CLI. We have an open REST API, and we also support netcom Yang, so you can use northbound controllers such as NSO or others to control the platform or a cluster. Of course, then we have the issue with people are simply comfortable with dedicated hardware appliances. So this provides a hybrid model, so to speak. So we've linked the NFV software with the UCS server. So it's kind of one package altogether. And in terms of performance, we're seeing very few use cases now that we've the x86 has come a long way, and we have things like DPDK, SRIOV, and PCI proof. There are very few use cases left where you need that dedicated purpose-built appliance. Okay, if you could go to the next slide, please, Nathan. So what is the CSP 2100? As Nathan said, this is an NFV appliance, so it comes with everything together, the hardware, the software, so you can be up and running in about 5 minutes. So if we start here at the bottom here, it's built on UCS servers 1 and 2 RU platforms. About a year and a half ago when we started shipping the platform, we had a fixed platform. Now we've just introduced modular platforms, so you can choose the processors you want, how much memory you need, disk drives, which NIC cards that you need and how many. So it's so based on the particular VNFs that you're running and the capacity and throughput you need and the performance, you can pick the appropriate configuration. And of course, on top of that, the software layer, all the value is around the CSP software that we've developed over the last 2 or 3 years. We're leveraging, CompD under the covers along with Linux. And we also do use OVS, and then for performance, both with Avi Networks and other services, you do have the ability to leverage a PCI pass-through or SRIOV in either a VEB mode, which is a virtual Ethernet bridge mode, or a VEPA mode. And that's VEPA is virtual Ethernet port aggregation. So what VEB allows you to do is it's a kind of an internal hardware bridge. So for VM to VM traffic on the box, if you don't want the traffic to leave the host itself, you can leverage that particular mode. Now with VEPA, if you want all the traffic to leave the host and let the upstream switch to all the if you want your top of rack switch to do all the switching, you would use the VEPA mode. And this is the most secure mode and also the highest performing mode. And then finally at the top, you can put just about any KVM-based service on the platform today. So we have the CSRs running, which is the virtual router from Cisco, XRV 9000, another virtual router from Cisco, ASAV. And of course, we have Avi here, and then we're also supporting a number of third-party virtual services. And then, as I mentioned previously, you can interact with the box through the GUI, the CLI, a REST API, or netcom. Okay, next slide, please. So why are customers really considering the CSP 2100? And I think almost everyone comes back and saying it's just the ease of use. We've built a very intuitive GUI, so you can get up and running, within a matter of 5 minutes. And so it's the operational simplicity more than anything. So that's what we've taken a lot of time to abstract away as much complexity as we can. The other thing that we have is the automation through the REST API and netcom. More and more we see companies wanting to move to automation, so we expose those capabilities. And also with clustering for high availability. So today you can cluster out to via the GUI up to 10 nodes, and we're adding support for even more so. And then lastly, performance. Anytime people or folks start talking about NFV, performance always comes up, and we've handled that through these Intel capabilities of PCI pass-through and SRIOV, so we're able to bypass OVS and the hypervisor layer. We also support, we do support OVS today, so there are services out there that do not support SRIOV, so we do support those as well. Next slide. So where can I use this particular appliance today? Just about any place in the network today it's being used, across the network. So, and if we just take a look at, for today, the load balancing use case, so it is being deployed in, within colos, which are being used as DMZs, both Avi and the CSP today, or the DMZ may be at the WAN edge of your data center, so that's another particular spot for it. And then within the core of your data center, or even in the server farm for east-west traffic. So there are numerous use cases, for both the CSP and load balancing today.
Okay. So from my perspective, from Avi, what this really means is that you can have a drop-in replacement for an existing antiquated load balancer that you need to upgrade. You can drop this in, and it's a full stack of a load balancer with all the underlying hardware components. Plug it in, you're pushing tens of gigabits of throughput right out of the box. We have the ability then to suck in the configuration from existing competitive load balancers as well, and you're good to go very, very quickly. And from your perspective, though, that may also mean that this could be a load balancer today if you needed that. It's something where if you had some other reasons, you could have that same hardware, though. You could reallocate or repurpose to something else if it needed to become a WAF or if it needed to become some other device. So you can repurpose and reallocate hardware rather than having to repurchase new hardware for every single project or any time that capacity has changed between now and the next however many years into the future. So it makes for a much more versatile versatility. And then from Avi's perspective, that's great too, because that gives you the infinite scalability to say, hey, I'm getting hit with a DOS attack. I need to scale up my capacity to defend against it, so I'll just go and spin up a couple more load balancers so I've now doubled my capacity to defend against this. So it's something that gives you great versatility while still giving that ability to just have a drop-in replacement for that existing infrastructure that you might be replacing. So I'll go and do a quick demo and just kind of show off a little bit about Avi Networks and what this would look like from, let's say, from a management perspective. So I'm going to go and drop into one of our Avi demo controllers. So I'm logging in with my username and password. You can obviously manage this in the CLI from the GUI or from REST. The GUIs obviously tends to be a little bit prettier, so I'm going to start there. So from what I'd said before is that Avi is a bit of a next generation take on load balancing and application delivery. And it's exactly what you're used to in the past, where we get a request, we load balance across X number of servers on the back end. But what's really important, what's really interesting about where the industry is going is the industry is all about how do I reduce OpEx? How do I reduce the complexity across the entire system? If that's deploying the load balancers in the first place, if that's deploying new applications onto a load balancer, or if that's simply going and managing and troubleshooting. The most common scenario is that the application gets deployed, somebody has a problem, and they immediately blame the load balancer, and the network team is having to defend itself and do packet dumps and traces to try to figure out if it's their problem or not, and it turns out, oh, it's not even my problem, it's an application problem. Some of our customers have coined this mean time to innocence. So I'm dropped into the Avi controller right now, and I can see a list of my applications here on the left, and I've got some of these applications, like this scale out one has a health score of 32. That health score is saying that the application is up and it's working, but it's not working very well. And so it's simply giving some indicators saying this is something I may want to drill into to figure out what's going on. It has a performance score of 60 out of 100, so that's the end user experience. Is the site fast? Is it slow? Is it sending out errors? I've got a resource penalty, and that could be CPU, memory, disk, either on the load balancer, or that could even be on the back-end application server. So that way, if the apps guys are saying, hey, your site's slow, I can say, well, actually, I'm looking in here, and it says that your servers are running out of CPU, and that's what the problem is. Or I've also got a security penalty, and that could be that I'm getting hit with a denial of service attack, or that I've misconfigured SSL, and I'm vulnerable to Poodle, or some other attack like that. So it gives me a lot of different choices. I'm logged into this one controller, and this one controller I can see a number of these different clouds and different places where I have my load balancer infrastructure and these applications deployed. So I can go and drill into any one of these ones, but I'll drill into this demo Avi application. And you can go and hit this app directly, demoavi.com. But from this application, we can go and see, let me change the default time so it looks a little prettier here. So this is showing the last 6 hours, and our default view of the world is not just bits and bytes or packets per second. Our default view of the world is really more around the end user experience. So on average, the end users that are connecting to this site are taking just under 100 milliseconds to connect to our data center. It takes about 1 millisecond for the server to pick up a connection, about 32 milliseconds for the server to generate the content, and our network is really nice because it's delivering this pretty quick. So the average end user experience, end user time here for this web page is 135 milliseconds. And a little bit ago, you see that bar jumps up quite a bit higher, and it went from 130 milliseconds to 177. Right now today, if a customer calls in and says, hey, your site was slow last night, what do you do about it? You can't TCP dump. That was already happened in the past. This is what Avi gives you, is that significant visibility and telemetry data that just hasn't been available to the network engineering teams in the past. And this shows me that this orange bar got higher during this point in time when things got slower, and I can see that this is my application response started getting really bad. So I may want to go and drill in further to figure out what's going on, why is this happening. But already your mean time to innocence is that quick to say, this is not a network problem, this is an application problem. The app teams, I can turn it over to them right there, or I can drill in further to tell them exactly what the problem is. So on the right here, I'm doing some content switching across multiple pools of servers. I can go and look at this. I can look at my view of the world from just a throughput perspective. From throughput, it just looks like, yeah, life is basically pretty good. There's no issues. And that's where this end-to-end timing really shows that actually there is some issue here. There's something going on. And I can see different views of the world here. Under the requests on the bottom, I'm getting about 2% of my requests are resulting in errors. So that's, again, something I may want to go and drill in further to understand what's happening and why. So this this whole process starts by looking at this health score, saying my health score is not ideal. I've got a little bit of a degradation on my performance, a little bit of degradation on some other areas here, and so I can start drilling in further. So if I drill into the logs, these load balancers, these are simply just doing the data plane. So this is a little bit of a different paradigm from what's been done in the past, where every load balancer is a dedicated island of load balancing by itself. In this case, the Avi load balancers are all individually data planes that are horizontally scalable, and all of the management is all being done on the controller. I'm not touching the load balancer whatsoever. I've not logged into it. But what these load balancers are doing is they're able to grab all this telemetry data as well as all these logs. They forward them off to the controller, and the controller is now where I'm sitting, and I'm going to go taking a look through these logs. So right now I'm looking at this application for the past 6 hours, and I can see that I've got about 8,900 logs here, and I'm showing right now just what we call significant logs, which are errors. Well, I can also show non-significant logs, meaning traffic that's not an error. But if I go and expand any one of these logs, I can see that this is a user that came from the United States with Mobile Safari. They've negotiated SSL with TLS 1.2. Everything about their connection, perfect port secrecy, and I can see which load balancer they went to, which web server they went to on the back end, and everything about their connection. I can drill all the way down into every header that the clients and servers are sending. And this transaction, the server sent back, and we sent back to the client to 200, meaning that a good web page. But we still mark this as significant because we're saying that this application had a really high application response time. So that app response time was 97 milliseconds. So everything in blue I can mouse over, filter, and click on that and say, let's filter for high app response times. And you'll notice that there's a really high big spike right here, which correlated with that really ugly spike on the previous page. So this is when I'm getting all these app response times. I can go and see, is there anything unique about the clients that are coming in, the browsers that they're using, what type of devices are they using. That's fairly benign. If I look at the server IP address, I see that all of these slow responses are coming from this one server. So again, I can hand that off to the apps guys and say, hey, this server's got a problem. And right now I don't necessarily know the answer why it has a problem, but I can tell you it looks like it's, it really had a big issue at this time. And as we drill in further, we'll find, hey, it looks like it's doing a log rotation every 6 hours because it runs out of disk space. So this is the type of power of what the next generation of application delivery can provide for you. It is something that really allows you to take a very complex issue or complex problem, break it down into where's the problem, triage it, and then provide you some ideas of how to go and resolve or troubleshoot this. So this is something where you can get very granular with things like searching through this traffic or being able to understand what an issue might be. So this is something that can be, this user interface can be shown to both the application teams and the network teams so that everybody's on the same page. Everyone has the same view of the world. Everyone has that same ability to go and understand the issue or what the problem might be. So right now I'm showing both what we consider significant logs, meaning basically errors, as well as non-significant, so good traffic. And I've got about 30,000 per second. And if I go and hit this site, demoavi.com, so this is the site that I'm hitting. It's on the public internet. Nothing too exciting about it, but I'll do demoavi.com/Nathan, generate an error or two. And I can even get very granular and do something like, basically this is like Google for your application traffic. I can do something like search for custom field or custom data, like such as Nathan. And that data was logged on the individual load balancer, funneled or pushed up to the controller, and the controller now has a full view into this, and I can go and drill into this and see what IP address I'm coming in from. I'm using Chrome as my browser, everything about this client. So I could go and add this user now to a blacklist and say, you know, discard if this guy ever comes in again. So that's the type of power of what this is providing for you. As yes, it's a load balancer, it's spamming packets across a bunch of servers, but it's something that makes it very, very easy to understand, to troubleshoot, and to really reduce that operational complexity of managing a large distributed environment like this. So to kind of show off a little bit more around, I've got an application here that we cleverly have named Scale Out Virtual Service. And so to give you an idea, I talked a little bit earlier about how if we have the ability to scale horizontally across multiple CSP devices. So I've got, in this environment, I've got a number of load balancers that are already configured. So if I go into my infrastructure, I've got a whole bunch of these service engines or load balancers that are configured on Cisco CSPs. So since that environment and that infrastructure already exists, now what I'll do is I'll go and drill into one of my applications here. And if I go through this application and go through, it's basically going to tell me that I'm maxing out the CPU on one of my load balancers. And so right now I'm pushing however much traffic I'm pushing. I'm currently running on this one load balancer. I have this set up right now in a manual mode, meaning that the system has to be manually scaled out if I need to increase capacity. I can have it be in a dynamic or an automatic mode, but then it would have already solved this problem before we even got to the demo, and there wouldn't be anything to show. So I put it in manual mode. Manual mode says that I'm currently running on one load balancer. I want to instead run on two load balancers. I'm going to distribute traffic across both of them, mirror the configuration, mirror the persistence tables and the SSL, mirror everything like that. So since I'm in manual mode, I have to go through this manual process of clicking scale out. And so what this is going to do is this is now going out to the data center, going installing and rack and stacking another load balancer and installing everything. Except in this case, you already have just that CSP infrastructure available for all your network services. So Avi's simply going to go and pick up some more CPU capacity and some more network capacity, et cetera, from that existing infrastructure. So you'll see these little icons here saying application scale out was just executed by Nathan. And after a couple of ticks, you'll see that my load generators are able to take this site from 300 megabit up to about 600 or so megabit of throughput. And so that's something that's very powerful. I didn't have to go and do any extra work to simply say, well, if this application needs more capacity, let me just go ahead and add another load balancer to the mix. So I'm now distributing traffic across these two load balancers by using equal cost multipath or ECMP upstream. So I've talked to that infrastructure, talked to the router upstream, and my controller said, hey, I need to go and distribute traffic across these two. So this is something that can be done through ACI for full automation as well. So it's a very powerful and unique way of being able to have quite a bit of control over what's happening, how to be able to distribute, and I can do the same thing as well if I want to go and scale back in and drop down to leveraging just one load balancer. So I can go and show through a number of other tasks and a little bit more on the UI side of things. But really what this provides is that I can have this be a drop-in replacement for your existing load balancing infrastructure that's going to give you more capacity, that's going to give you a much easier user experience, a much more powerful experience as well. And this is something that Avi also has the ability to automatically suck in configuration from competitive products, or if you've got something like ACE or something like this, and we can import that and run it through a config converter, and it spits out the Avi configuration at the end of this. We can support multiple data centers, et cetera. So what you end up with is really this cloud-like infrastructure. So with this cloud infrastructure, you then have that ability to say, I've got multiple data centers, et cetera, but I'm not managing individual load balancers. I'm not managing individual data centers. I'm simply managing and saying, here's my infrastructure. There it is. I can set up role-based access and allow my application owners to come in and just manage their applications. They can deploy, add servers, remove servers to their applications, but it's all going to take advantage of the existing infrastructure that I've already created. For instance, I'll go and I'll create a new application here, just do a basic setup. It's going to ask me this controller, this environment is currently deployed in multiple data centers. I'll select which data center I want, create a new application. I'm in basic mode right now. Give it an IP address. So right now, by giving it that IP address, it's resolving in DNS to whatever that destination is on the back end. Go and specify a couple of servers here. So I'm going to add a couple of servers and save. And this is now going to figure out, it's going to say it probably won't like me because I'm already going to have that created. I'm sorry, I got this created somewhere. And it won't let me reuse my same IP address twice because I've already got it in another tenant. I've also got multiple tenants going on, so my stuff gets used everywhere. So I got to go find a free IP address. But with this, I can go and deploy this. It'll go and pick the load balancer that has available capacity and has reachability to the back-end servers and to the front-end virtual service, and automatically go and push this out and deploy. So it's fairly seamless, fairly straightforward, unless you have already used that IP address somewhere else and is saying, hey, that's already in use for that IP port, et cetera. A little bit more on this. So you can go to, for Avi Networks, you can go to kb or knowledgebase.avinetworks.com, and this will walk you through everything about something like how to install Avi for Vantage, Vantage on this CSP 2100, and walk you through the steps of how to configure it, how to deploy this. And this is something where you can actually download the software from Avi's site and without talking to a human being, just click on this download option at the top and walk through and say download the software and run it in a trial mode. Deploy this on CSP, and it doesn't take that long at all. You can have this up and running in no time and be able to then try this out and use this in your own environment. So it's something we definitely encourage. You can fully self-service, which is nice for people that don't like to ask for directions. The directions are already there, so it makes it super easy. With that, I'll turn this back over to a couple more slides here on the on PowerPoint land. So as we wanted to talk a little bit about some existing kind of case studies and some other customers who have gone through this process before of saying, I've got a bunch of old load balancers. I've got some Cisco ACE. I've got some other products as well that are all coming up for renewal, and I'm looking at. I just want to have one solution across an organization, and I'm still, want to step into it a little bit. So a global financial company, one of the largest top 5 banks in the world, recently went through this process. And they found that just by deploying this onto CSP, that gave them the ability to deploy the load balancing infrastructure, and as well as the global load balancing, the WAF, et cetera. They had that ability to deploy a lot of these network services. And this is something that became a very simple deployment. And I think that most everyone was really surprised at how universally accepted that this was across the board. The application guys really appreciated the fact that they got a lot more visibility that they didn't have before. The network guys appreciated the fact that they're able to modernize their infrastructure and use something that's a little bit more scalable. It's, using, they can rely on the Cisco powered hardware. And at the end of this, also, they saved a significant amount of money by going with a more modern architecture that allowed them to leverage infrastructure. So instead of having pre-purchasing infrastructure for load balancing, for instance, they're simply pre-purchasing just generic compute that they're able to leverage for whatever they needed when they needed it. And that allowed them to save quite a bit of money and significantly increase the speed at which they're able to roll out this new infrastructure. So I think some of the benefits of this, I talked a little bit about some of the Avi specific architecture and software were essentially managed and all these capabilities. But ultimately what this really comes back to is that what people want to see, which is why is this beneficial for me? It's a lot less expensive because you're not over provisioning, you're not wasting a lot of infrastructure that you don't necessarily need. It's much easier to deploy. It's much easier to deploy a new load balancer, to deploy a new application on that load balancer, and easier to troubleshoot if there's an issue. Is it the network's problem? Is it the application problem? I can show you, and I can show you right away what the issue may be. And you have the ability to fully automate this, which is great. So that's something where the app teams can go and add and remove servers simply by sending API calls, and the network teams don't need to do anything. The network teams simply lay out the policies one time. They define all of that, all the security, all the network schemes, and then from there, the app teams can simply just go and use the load balancer from their piece of it, and you set up that roles-based access that's already pre-configured, and they have the ability to drop right into it, and they're happy. And that's what people want to see. So with that, we can show off a deeper dive, or if you want to see a custom demo of any of this, we certainly have the ability to do this remote, or if it's something where you're interested as well, Gunnar can certainly work with you on getting hold of some CSP hardware and deploying Avi on this, and you can see this in your own environment, and we're happy to set this up. Gunnar, do you have anything else you'd like to add to this?
Yeah, I just wanted to go over a few questions that we have here, highlight some of the questions. So I'm not sure if we covered this already. So there are some customers here that they're leveraging some of the older GSSs, or do you have GSLB capability?
Yes, absolutely. We do have GSLB capability. We've just this morning we did another call with another customer, just going over very much that is what that will look like to import the configuration from the GSS and be able to suck that into Avi and be able to provide that multi-data center. So I showed that we have multiple data centers, so I didn't show any of the GSLB functionality or capability, but yes, it's all there.
Okay, perfect. And then I think we had a question also about a web application firewall. I believe that's in beta or development. Is there anything you can speak to on that, when that will be out, or if that's available for trial at the moment?
Sure. So that's something that Avi is working on very aggressively, and we have been now for a couple of years. And it's something where with every version, we're continuing to add more and more security functionalities and security features and such. But to claim that it's a full web app firewall, it's pretty easy to make that claim. It's pretty hard to back that up. But for Avi, that's something where we won't actually be claiming that until we're 100% confident that we have the entire gamut of functionality that's necessary to block all any and all types of web app attacks. That is something that you'll see though coming out over the next basically in the next release, over the next 2 releases, which translates into, you'll see that about middle of this year.
Okay, thanks, Nathan. Another question that came up about if you have support or tools in order for people to migrate from from the legacy ACE load balancers.
Yes, absolutely. So we have a configuration import, and so you can import from GSS, from ACE, from NetScaler, from F5, from LTM, GTM, et cetera. So that's pretty common. Customers are looking at it going, hey, I've got 100 load balancers here with thousands of, in many cases it can be hundreds of thousands of lines of config. I'm not going to type all that in, and I'm not going to pay for 2 years worth of consulting to do it for me. So absolutely, Avi does support that ability to just import this. That's been something that's very important for us, is to make sure that we do it, and we do it without fat fingering any of this. So we just have utilities that do just that, import the configuration, convert it into Avi's format, and along with this, we can go through and we can walk through and say, we can just do a complete one-to-one swap in or swap out, or what we would generally like to do as well is we also take a little bit of a consultative approach and say, while we're doing this, we have the ability to change up a little bit of how you've architected this, and we can maybe do something more efficiently. For instance, most web applications are going to be HTTP port 80 and HTTPS port 443. And most load balancers, that's 2 virtual services. We can consolidate that into one virtual service and automatically do redirects from HTTP to HTTPS, et cetera. And the end result is that you're going to have the same functionality with half the configuration size, half the complexity. So we'll kind of walk you through some of these options to say, here's ways that you can improve and dramatically reduce the complexity of your environment. So either we do a one-to-one replacement, or we can take advantage of a couple of these additions to make things a lot more efficient for you. So that's something that's worked very, very well for customers that are migrating to Avi.
Okay, great. Thanks, Nathan. So let me a few other questions here. So I don't think we touched on it. So people are asking about if you have a device package for the Cisco ACI APIC.
Yes, yes, we do. We do fully integrate with APIC. I'm sorry I didn't show that off because it wasn't quite on the agenda for today. But absolutely, we're fully integrated with APIC. I believe the largest deployment of APIC is running on Avi. So we're quite proud of some of those customers, and we've got some great reference customers running on that. So we do leverage the device package, but we also take advantage of API integration between our controller and the APIC controller itself. And so that's something that's worked very, very well for us. Because we don't have a lot of these individual load balancers talking to APIC, it's our controller talking to the APIC controller. So architecturally, it fits really well because Avi's architecture is similar to the APIC architecture of distributing the data plane, centralizing the control plane, and then the central controllers can talk to each other and exchange data over the API. So that's one big difference with how we've architected this versus other kind of that more just, ad hoc load balancer active standby pairs kind of disseminate throughout the data center kind of approach. So it's worked very well for us.
Okay, great. So a couple other questions, and then we'll wrap it up. Let's see here, and I think you can look at these. If we don't get these today, we'll reply offline. So, and I guess a question on the APIC then, is that available for download from your website, or how do people how are they able to grab that code?
Sure. So you can go to avinetworks.com, and there's a download or try Avi button, and you can go right from there. Or you can work with your local your local Avi teams, and we can set you up and kind of walk through and even install this with you or for you if you want to see this live. So we can either do a full demo for you, or we can get you the software, get you a license key, et cetera, whatever you need to get going. So if you got questions about who to contact, et cetera, by all means, feel free to contact myself, which is just Nathan@avinetworks.com, or the email address on link there on the screen.
Okay. Yeah, I see, Edward, you're answering some of the questions, or some of the questions here you want to highlight. I see you've been answering a number of those.
Could you address the questions on stickiness based on cookie learning and header modification?
Sure. So for persistence based upon source IP address, based upon cookies, based upon session IDs, et cetera. So absolutely, the functionality that you expect and require from a load balancer is there. It's checkbox functionality to this. Things like header modification. You can either do this through our policies, which is a point-and-click ability to configure if-then logic to say if the header looks like this, then redirect to that other server. Or you can also, if the point-and-click is not flexible enough, then you can do something like what we call data script, which is a scripting language for manipulation of data plane traffic. So what we find, though, is that when we're importing from competitive products, usually competitive products that have got scripting languages or rules, we're generally able to reduce about 75% of that of those rules simply via just native functionality of the system or from just point and click. For things like HTTP to HTTPS and enabling rewrites of headers and things like this, literally you can hit one checkbox and it'll just do all of that for you. So that's how we're able to eliminate a significant amount of the complexity. And I think people are always very surprised when they see this and go, oh, wow, that was not quite as hard as I thought it would be. So it is something that makes it very, very powerful for Avi, and we're certainly very proud of that. So there's an example of one checkbox to say, just do everything for SSL. Okay. Good question.
Okay, any other questions you want to highlight, Edward?
I'm just taking a look at the chats now. I don't think, I think, Nathan, you addressed the header modification. We can do that. And is load balancing capable to provide stickiness based in cookie learning? I think those were addressed. The others, I think we were addressed on the chat window.
Perfect, thank you. By all means, feel free to reach out to us after this session, and we're certainly excited to do just kind of a one-off answer of questions or walk you through a little bit further if you want to see more details about how this works under the hood, or if you'd like to try this out in your own lab. That's something where we can pretty easily put you in touch with the right people to try out CSP and put some network services on this. So looking forward to that.
All right, great, thanks, Nathan. So what we're going to do today, we're going to go ahead and conclude. I will go ahead and send out the recording. So if you missed part of this or missed the beginning, so you will have that within 24 hours. I'll send a link to it so you can go through it. And like I said, feel free to reach out to either Cisco or Avi. So thanks so much for taking the time today, for attending, and enjoy the rest of your day. Thank you. Bye-bye.